Hello, vintage computer friends. Today it's the 1981 Microprofessor MPF-1 Z80 based SBC single board computer again on the workbench, and today we are going to run a couple of programs which I got from another fellow microprocessor enthusiasts from the German classic computing vintage computer forum DISCMIX. So DISCMIX in his collection also has a few microprocessors, and in some of them he noticed that he has user programs in EPROMs, right? So this socket here, U7, is usually the user program EPROM. 2716 is usually there, mapped into the memory region from 2000 to 27FF, right? 2 kilobytes EPROM. And so he was kind enough to read out these programs and send us the bin images of these EPROMs, right? And yeah, so I have reconfigured my microprocessor, right? Because you can either have an EPROM here, or you can actually put another 2 kilobytes of 6116 SRAM in there, right? And for that you got to change these jumpers here, so you have to cut a couple of traces on the PCB, and then you can configure the U7 socket to either house a 2716 EPROM or a 6116 SRAM chip, right, which gives you then an additional 2 kilobytes of RAM. And of course I then opted to simply swap PicoRAM 6116 in there, so that way we can now load programs from SD card, right? And in particular I'm trying to run DISCMIX EPROM bin images, right? So, but natively PicoRAM does not support bin images yet, right? So it needs to be a hex file, and I'm going to demonstrate how to convert a bin EPROM image, right, such as the ones that I got from DISCMIX with his programs, convert them into a hex file, and so that it can be read in and fed into the microprocessor by PicoRAM, right, 6116. So let's have a look. So yeah, and in my previous videos we always used PicoRAM at the U8 position, right? And U8 is of course where the system also has its RAM, right? So if the monitor variables are in here and the stack and so on. So that's the main RAM basically, and that goes from 1800 to 1FFF. And all the programs that I demonstrated previously, right, and that we wrote together, for example, using that online web assembler, right, and then we assembled that and produced a hex file and put it on PicoRAM and, right, Towers of Hanoi, and so we implemented together. These programs all, you know, they don't really work in U7 now, because they are of course written for the address range from 1800 to 1FFF. And only some of them use relative addressing, right? And programs that use relative addressing, they can then, you know, still work, for example, in U7, which is a different address range. Otherwise, of course, you need to relocate the program, and I didn't do that. So most of the programs that I have here, right, which are now loaded by PicoRAM, right, simply won't work. But one of the programs that still works here, for example, is this counter, I think. If we start this at address 2000 now, even though it was written for address 1800, that one still works because it only uses relative jumps. But what you can also see is that there are these U's here, right, and this is because the display buffer is not initialized correctly, right? So the program should actually initialize the buffer in this region now, but it, I think, initializes it in here, or vice versa, right? But so that means that's not blanked out correctly here, but at least the program is still running, right? And other programs, the ones that we wrote together last time, like the Towers of Hanoi, unfortunately don't work in U7, but they only work in U8, as explained, right? But yeah, let's have a look at the programs that we got from DISCMIX. And I already converted the bin into hex and have it here on PicoRAM, right on the SD card. And so one program we got. And of course, I mean, I needed to put PicoRAM now in U7, right? Because his programs are originally coming from U7, from the EPROM, and they are in the 2000 to 27FF region, right? So that's the first one here. So very nice telephone sound tone, right? That's one of the, I think, in one of the manuals, experimenters handbooks or so, there is this program, right? I never typed it in, so it's nice to have that now. I'll also upload this to the GitHub. And here, Rafa from Tenerife, right? So you asked me in an email for additional sound programs, and so yeah, that might be a nice one to feed to your PicoRAM, right, and to your microprocessor. And then there is another program at 2300 according to DISCMIX. That sounds like Greensleeves to me. Very nice. And then I think there should be one more program. Let's see if we can also get that to run at 2200. So the conversion process from bin to hex is really extremely simple. So you have a 2716 EPROM image here, a bin file, right? And I'm simply using the MiniPro EPROM programmer software. So just select, you know, a 2716 here, 2 kilobyte EPROM, right? The manufacturer doesn't matter, right? Because we are only using it for conversion, not for programming. Then we load the bin file, binary, right? And yeah, that looks like valid Z80 machine language, right? And now we are just going to save that as a hex file, change the type to hex and give it a reasonable name, prox hex, and now we are almost good to go, right? But we still need to remove the leading addresses as well as the checksum. So Emacs is a convenient tool to do this. So the first line is always some kind of identifier, I think, for the EPROM or other meta information, as well as the last line that can go away. And then we see that there is always a colon here, as well as a 32-bit address, right? And that's going to be removed. Eventually I'm going to augment the PicoRAM reader such that it can actually deal with that kind of hex format as well, right? So, but for the time being, you know, we have to edit the file, but eventually it's going to be able to also read this standard hex format. Then we won't have to modify these files by hand all the time again, but it's not a big deal anyhow. So we use the rectangle mark mode again in Emacs, right? So that way we can select columns of text rather than just paragraphs and individual lines, right? Which is convenient, so we can just cut that out. And also the same for the checksum byte at the end. And there you go. And now we only need to save it as MPF extension, prox MPF microprocessor. That's what PicoRAM is looking for on its micro SD card. Yeah, so now all that's left to do is, you know, grab the file and put it on PicoRAM's SD card and fire up your microprocessor, right? Alright guys, that's it for now. Thanks for watching. Bye.